For those who weren't, we are, like we did for solar, we're looking at carbon footprints. This is some data that the government pulled together in one of their post notes a few years ago. So you've got the different technologies here, different renewables. Wind power has pretty much the lowest carbon footprint that you can achieve for any power generation technology. The figures that we've got here are about 5 grams. I'd say that's pretty conservative, actually. So I would expect anywhere from 5 to 20 grams of carbon dioxide equivalent per kilowatt hour. So again, that's looking at all of the greenhouse gas emissions from extraction of raw materials to installation, to operation and maintenance, to decommissioning, adding them all up, dividing them by the lifetime output of the installation. So I would expect 5 to 20 grams. And as I say, that's basically as low as you can get. It's pretty similar to nuclear. There aren't really any technologies that have a lower carbon footprint than that. You do have some other emissions, and of course, pretty much all of this is associated with building the thing and installing it. So you're using lots of steel. If you're onshore, you might use a lot of concrete. If you're offshore, it's even more steel. So we'll look at that shortly. So the majority, normally more than 95% of the life cycle emissions come from construction. Other things to think about in terms of environmental impact. You could say that noise was an environmental impact. We've got a little diagram here to show distances and noise levels that you would expect for a relatively large wind turbine. You've got 2 types of noise. Firstly, aerodynamic noise, so just the sound created from the blades passing through the air, and then mechanical noise, so the sound of the components within the turbine. Remember, you've got a gearbox, you've got a generator, you've got some amount of friction to create a bit of noise as well. And here's where those lie. So here is a turbine. This first ring is 150 meters away from the turbine. You would expect somewhere around 45 decibels. Obviously, that varies depending on what turbine it is and so on, but as a rough guide, about 45 decibels. The thing to remember here is that the decibel scale is not linear, so 45 decibels is much louder than 44 decibels. 45 is kind of equivalent to typical household noise levels, so it's definitely noticeable. It's not loud, but it's definitely noticeable. As you go further away, if you get to about 400 meters away from the turbine, you're looking at the mid-30s decibels, which is equivalent to kind of typical nighttime noises, so ambient noise that you might hear through windows, that kind of thing. So it is still audible, but it's quiet. In most cases, people do not live within 400 meters of a large wind turbine. Normally, they're quite a bit further away. Quite often, wind turbines onshore are built on hilltops or in fairly remote areas. So normally they're built outside of urbanized areas. So this isn't typically a problem. One thing I do want to mention, just because you may have come across it, is you sometimes come across this idea of wind turbines causing low frequency noises, which cause health problems. So there is this thing called wind turbine syndrome, which gets thrown around every so often. The idea there is that the low frequencies can cause some sort of mysterious variety of illnesses. There doesn't seem to be any evidence for it. It is true that the larger the turbine, the more low frequency noise it creates, but there doesn't seem to be any solid evidence that this low frequency noise has any effect on people's health. So generally speaking, I think the kind of medical consensus at the moment is that it's mostly psychosomatic. It's not a proper physical phenomenon. You may come across it every so often, but as I say, there's not really much evidence for it. Other things, other effects that it has, electromagnetic interference is one. So it can interfere with radio signals, with TV signals. When they're designing very large wind farms, they have to do a lot of consultation with the military because it can disrupt military radar and things like that. So when you have, particularly offshore, there'll be radar stations that obviously are trying to look out for, you know, incoming planes and stuff. And you have to consult quite a lot to make sure that the design and the orientation of the wind farm is in a way that it minimizes that disruption. Visual impact is going to be something to consider for pretty much any large-scale renewable technology. And it's certainly the case for wind. You're probably aware that a lot of people don't like the look of wind turbines. They are big, so they are very obvious. We've got here a turbine with a total height of 120 meters. So that kind of matches with some of the smaller ones that exist now. So if you recall, I said that some of the new turbines, the 6 and 8 megawatt turbines, they might have a hub height of about 120 meters. So then if you imagine where if the blades are rotated vertically, if one of the blades is pointing vertically, the total height is probably going to be 200 meters, something like that. So they are big things. That has been one reason why more of the development has started to occur offshore. Yeah, I quite like the way they look. Some people don't. Up to you. I'm going to mention birds again. Now, I'll go through this, and then I want to talk about what we said last week as well. This is a complaint that comes up a lot with wind power, so I wanted to try and clarify it a bit, that wind turbines kill birds. Yes, wind turbines kill birds, but if you look at it in context, there's an analysis that tried to do this in terms of amount of energy output. So, approximately 0.3 birds per gigawatt hour are killed by wind power in a country like the USA. You compare that to fossil fuel power generation, and it's about 5.2 birds per gigawatt hour. The UK likes pet animals. There are lots of cats in the UK, and our domestic cats kill 55 million birds per year. So, I have a cat, but luckily she's very lazy, so I don't have to worry about that problem. So, trying to put it in context is all we're doing here. Yes, they kill birds, but it's very, very minimal. It's lower than the other power alternatives. So I would argue it's not a problem. One thing that is related to that is that planning permission for this kind of thing has to take into account stuff like this. So, okay, it's not many birds, but what if it's a very rare protected bird? That does happen, and I'll give you an example shortly. And when they're doing the planning for these kind of things, they have to take into account any local populations of birds and migration patterns of protected bird species and make sure that it's not going to be a problem. So I'll give you an example of where that has actually cancelled a project later on. Other environmental impacts. So we talked about carbon footprint across the whole life cycle, but what about if you look at depletion of resources? This is the same principle as carbon footprint in that you're looking across the entire life cycle, but instead of measuring greenhouse gas emissions, you're looking at the amount of minerals and metals that you're using throughout the whole life cycle and then summing them all up. So here's a few examples of different types of power generation again, and you can see that wind does have high depletion of elements, particularly offshore wind. A lot of onshore wind, the base is concrete, whereas offshore it's typically a big steel monopile, as you can see over here. So you're basically at least doubling the amount of steel that you're using for offshore, a little bit more in fact. So that is a concern for wind, and there's a couple of things that you can do about that. One is that these figures don't take into account recycling at end of life. There's no reason why you can't recycle a huge amount of a wind turbine. The blades are often made of glass fibre, so they're normally downcycled. They might be used for construction or something like that. But the tower is steel. Most of the components are copper, aluminium, and there's a lot of them. So a typical turbine, a large one, will have about 400 tons of those materials, and that's not considering this this foundation. That's just the turbine itself and the nacelle and everything. So there's a lot of value in those materials. In reality, you're not going to just lose them. You're going to recycle as much of it as you can. So that should reduce this impact quite a lot. One thing to bear in mind, though, is that you cannot recycle the entire thing if it's offshore. Normally what they do is they will cut it off a metre or two above the seabed. The reason is you could extract the whole thing from the seabed, but it causes loads of disruption to the sea surface. And of course that means you're disrupting marine life, you're disrupting the ecosystem. So to try and minimise that a bit, they normally just cut through it at this point, recover the rest, take it away. Another thing that is quite common in the wind sector is this idea of repowering. I don't know if you've come across that. The idea there is that you maintain the foundations, but you swap the turbine at the end of its life. So the turbine probably has a design life of maybe 20 years, something like that. The foundations could last quite a bit longer. So you could wait until this reaches the end of its life, by which point there will probably be bigger, more efficient turbines. You take this away, recycle it, put another one on the same foundations, and again, that minimises your overall impact. But it is something to think about. It's also driving the design of turbines as well, this resource consumption. Not just for environmental reasons, of course, because resource consumption also means cost. And ultimately, that's what's driving most of the innovation. So if you look at offshore, here's the picture we saw before. That's the steel monopile, and that's normally driven roughly 15 meters into the seabed. So loads of steel required, tricky to install. And of course, the more you go further away from shore, the deeper the water is going to be, the longer that needs to be, and the more it's going to cost. So a lot of the new designs are looking at something like this, where the turbine actually floats and is tethered to the seabed via high-strength cabling. And at the bottom, you either have a ballast, like a big piece of concrete, or you have a suction design, or you have some other design, so that you're minimizing the resource consumption of the foundations effectively. That's being trialled and has been being trialled for a few years. There's this place called High Wind Scotland Pilot Park, which has been running for a while already. So that's a 30 megawatt demo project, 30 kilometers off the coast, but the water's really deep. So most of the ones we've talked about so far offshore, the water has only been 5 to 20 meters deep. This one's 95 to 120 meters deep, so it's a whole different ball game. And if you were to try and do that with a monopile, it would cost an absolute fortune. So doing it with this cabling system, if it works, is much more sensible. It means you've got lower cost, access to more resources, and a lower environmental impact. So it's a triple win.